Welcome to Every Animal Has an Owner, a mostly large animal podcast for veterinarians and the people that depend on them.
Diagnostics are crucial for us to ensure that we are actually targeting the right viruses. Like I mentioned, there are viruses that have many different serotypes or strains. And if all we know is, oh, this is rotavirus, we need to know more. And the only way to do that is diagnostics. There are viruses that cause similar clinical signs in animals. For example, EHD in blue tongue in white-tailed deer, or influenza and astrovirus in swine. They can cause similar clinical signs, and without diagnostic testing, we don't know how to prevent diseases or treat them in the case of if they have an active infection on the farm. So diagnostics across the board are what we need, what the veterinarian needs to ensure that the animals are getting the appropriate care. SPICE is what we have termed our process of analyzing the information we get from the diagnostic lab and then taking that information, that comparison from the diagnostic lab and what we have in-house, and that analysis, that deep analysis that we do to determine what we need to put into the vaccines for them to be successful in the animal. That's SPICE. So it includes all of the analytical things that go into it. Bioinformatics is huge. That's probably the bread and butter of our SPICE is bioinformatics. And then all of the human decisions. This isn't AI or anything. These are human decisions, eyes on these charts, hours spent analyzing to ensure that we are providing vaccines that will work. Bioinformatics takes those sequences that we get from the diagnostic lab and compares the amino acids to the amino acids in our constructs to determine how similar those are. Over the last year, we have developed new things in our bioinformatics to go deeper. So not only are we looking at sequence to sequence homology, so how well do those sequences match, but understanding that proteins are not linear. Proteins are folded. They fold in specific ways based on their electrical charges. And we have a program now designed by our bioinformatics team that predicts the folding of those proteins. So we can predict the folding of the protein that we got from the diagnostic lab sequence and compare that to the folding of our construct sequence. And that allows us to really understand when this protein is put into the vaccine and that vaccine is used in an animal, what is the antibody response? On the outside of those proteins, they're called epitopes. So not all of the protein is exposed, right? There's internal structure of a protein that nothing can see. So what we care about is what's on the outside of that protein that will elicit an immune response. It will create an antibody in that animal. So we want to match the protein structure, not just the sequence. And that's what our bioinformatics team has been able to do.